It's Advent of Code 2020, day 13. The problem is called shuttle search. We've ended up on an island that we didn't want to end up on just because our ferry had to make an emergency stop at a nearby port. So we want to figure out how we can get to the airport on this island so that we can continue on our trip. And the way we're going to get there is by bus. So we have a bus schedule that we've been given as part of our input. So each of these buses has a name or an ID, which corresponds to the number of minutes, sort of like the interval in minutes that the bus arrives at the port. So every 7 minutes, this first bus will arrive at the port. It then goes to the airport and makes other stops and then is back again in 7 more minutes. Similarly, this does 13-minute round trips. This one does 59. These X's are buses that are not out of service, I guess. So we want to look at this bus schedule and figure out what's the earliest bus we can grab to get to the airport. But we aren't going to be to the bus station until so many minutes after this is like our earliest departure time. So I guess we have to get to the bus station. So it'll take us, in this example, 939 minutes to get to the bus station. And so then after that, what's the first bus we can take? So all buses depart from the bus station at 0, like a 0 timestamp. And so then they're just going to continue on their cycle, kind of like this. You can see every 7 minutes, this D represents the bus arriving or departing, however you want to think about it. And so you imagine there's all this time that's ticked before this, but we get all the way down to here. Our arrival time at the bus stop was 9:39, so the earliest bus we can take is at 9:45. We can hop on bus 59. So we take that ID, 59, and we multiply it by the number of minutes we had to wait since we got to the station, and that's going to be our answer. So let's grab this input and we'll think about a solution. It might seem like the way they're setting up the problem that we have to do some sort of simulation of all of the bus movement. But what I'm recognizing is that we can use, I believe, a modulo, do some modulo math to figure out which of the buses is going to arrive most closely to the timestamp that we're going to be there, and then we can proceed that way. So let's open up Pry and think through this for a second. Imagine I have an arrival time of 20 instead of the 9:39, and I'm dealing with bus 7. So the bus starts at 0, it eventually comes back at 7, it eventually comes back at 14 minutes, eventually comes back at 20 minutes, so on and so forth. So if I were to do 20 mod 7, I'm going to get 6. And that's because we get to 14, and then there's another 6 remaining before we get to 20. But the bus isn't there yet. 20, we're still 1 minute out from the bus getting there. So what I want to do is take this mod value, what we get out of the remainder, and we want to subtract that from the cycle of the bus. And that's going to let us know how many minutes we have to wait from the closest, from our arrival time to the next subsequent bus arrival. So I'm going to subtract that and I get 1. Similarly, if we were dealing with 59 and the 9:39 example, we could mod that. 59, and we'd get 5. Which is just like we got down here. So with that in mind, I think we can code up a solution. So let's make a directory for today. It's day 13. So cd into day 13, and we will create our part1.ruby, and we will also create a sample.txt file, which I'll paste in that input there. And now we will read that in. And so the file is going to have 2 lines. So I'm going to split on those lines using a regular expression syntax. Split on the new lines. And so we're going to get 2 pieces back. The first piece is going to be our arrival time, and the second piece is going to be bus listing, I guess. And so we need to parse the bus listing a bit further. So if we, sorry, trying to jump over to this file real quick. So remember, we have something like this. We want to parse out these IDs, which reference the time cycle, and we want to ignore the X's. Cool. So I'm going to say bus listing.split on the commas. I'm going to say filter. I want to filter out things that, yeah, I guess if it doesn't equal X, then we'll keep it. And then we will map that over symbol to proc to I, so we get a list of integers. So we'll call this sort of buses in service. So now we have buses in service. I think we want to iterate over each of these and do the modulo stuff that we did. So buses in service dot be a map bus ID. Oops, gotta open up a do block. Keep that up there. And so for each bus ID, we will say bus ID minus arrival time mod bus ID. So that's what we did before, and so that'll produce sort of the different values, and we'll want to find the minimum of this set of values. Yes, we'll do that. I guess earliest departure after arrival is kind of what that value is. And then the bus IDs, we'll say bus ID is departure after arrival. So that gives us sort of an array of these tuples, and now we want to find the minimum where we minimize this second value. Just like we had over here, this was 5, this was 6, so we want to minimize this this value to find the one we're looking for. So we'll say min, and we'll get a bus ID and then earliest departure. And then, yeah, it's that we're minimizing. And then finally, we have, boy, what do we want to call these? I guess just, so it's going to return this tuple, which is our min tuple. And we're going to have 2 values that we can destructure out of here, the bus ID and the wait time, I guess is what it is. And so we'll put out bus ID times wait time, and that should be our answer, part 1. And it doesn't like our file.split because I did the destructuring wrong up there. So let's get rid of those and try that one more time. String can't be coerced into integer. Huh, what's that dash? Line 8. String can't be coerced into integer. Bus ID. Oh, sure. I got to turn arrival time into an integer as well. Did I type 2ID? Oops. Ooh, having a handful of typos here. Okay. And then min is an undefined method for an array. Huh. Maybe I can't call min with a block. I thought I could. Ruby enumerable min with block. Oh, I see. It takes 2 values. Okay. So we need to give it like we need for this block to sort of define a comparator function where given any 2 values, so any 2 tuples, how do we compare them? So yeah. Okay. So let's try updating this. Tuple 1 dot last, tuple 2 dot last, because we don't care about the bus ID in this part, we just care about comparing this last value in the tuple. So then I'm going to call these incoming arguments tuple 1 and tuple 2, and we will try that now. 295. Is that, yeah, 295. Okay. So let's give this a try with the full puzzle input. Do a command A to copy that. We'll bring it over here and we'll create an input.txt. There, that's pasted in. We'll save, jump back over here and read in that file instead. And let's see if we have an answer to part 1. 6568. Okay. All right, 6568 is going to get us a gold star. Cool. Thanks for watching this part 1. In the next video, we'll check out part 2.